Hi everyone, today we are going to learn lecture 3, subtopic solid. For learning outcome for subtopic solid are A. Explain the fixed shape of a solid. B. Apply the kinetic concept to explain the following process include freezing or solidification, melting or fusion, sublimation, deposition. C. Differentiate between amorphous and crystalline solid. D. State the following type of crystalline solid with appropriate example. Include metallic, ionic, molecular covalent and giant covalent. For learning outcome for subtopic phase diagram are A. Define phase, triple point and critical point. B. Sketch and differentiate the phase diagram of water and carbon dioxide. C. Identify triple and critical point on the phase diagram. Properties of solid. For properties of solid, particles are arranged closely together, only vibrate and rotate in fixed position, rigid arrangement and cannot move freely. Has definite shape and volume, has strong forces between the particles, has high densities, non-compressibility, extremely slow diffusion and less energy compared to liquid and gases. Freezing or solidification is a process in which a substance changes from liquid to solid state. This reaction is exothermic reaction when the heat energy is released to the surrounding. In terms of kinetic molecular theory, when the temperature of liquid is lower, the average kinetic energy of the liquid molecule decreases. The liquid molecule vibrate at slower rate and move slowly. When the molecule collide, the attractive forces of the molecule can now overcome of those molecules with low kinetic energy and hold them in fixed and orderly arrangement, so liquid changing into solid. Melting or fusion is a process in which substance change from solid to liquid state. In terms of kinetic molecular theory, when the temperature of a liquid is increased, the average kinetic energy of the liquid molecule also increases. The liquid molecule vibrates at higher rate and moves faster. When the molecule has sufficient energy to overcome the intermolecular forces that bind them, they are free to move. So, solid change into liquid. Sublimation is a process in which a substance changes from liquid to gaseous state without passing through the liquid state. Example, dry ice, freeze-dried foods. In terms of kinetic molecular theory, when the solid molecule has enough energy to overcome the intermolecular forces, it changes rapidly into gaseous state. Molecule able to move freely. Deposition. Deposition is a process in which a substance changes from vapor to solid state without passing through the liquid state. The opposite process of sublimation. In terms of kinetic molecular theory, when temperature lower, the vapor pressure moves slowly and become closer to each other. Held together by a strong intermolecular forces enough to hold the molecule firmly or in a definite shape, vapor turn to solid directly. Two types of solid, crystalline and amorphous. What is crystalline solid? In crystalline solid, the particle, atom, molecule or ion are arranged in an orderly manner. It is formed when a saturated liquid is cooled slowly. Each atom, molecule or ion occupies specific position. Example, salt, sugar, pyrite. For amorphous solid, they are called amorphous, which means without shape or form. Non-crystalline solid, particles are randomly arranged and have no order structure. It is formed when a saturated liquid is cooled rapidly. Example, glass, plastic, gels. This table shows difference between amorphous and crystalline. Amorphous is non-crystalline solid, whereas crystalline is crystalline solid. Amorphous when the structure, crystalline or the structure. Amorphous form when cooled rapidly, crystalline form when cooled slowly. Amorphous no definite melting point, crystalline well definite melting point. Amorphous shatter irregularly. Crystalline shatter to crystalline shaped pieces. We have 4 types of crystalline solid: ionic, molecular covalent, metallic and giant covalent. Ionic crystal. The particles are made up of cation and anion respectively. They are electrostatic forces of attraction between cation and anion. Example, ionic crystal of sodium chloride. Metallic crystal. The particles in metallic crystal are metal atoms of the same metal. Example, sodium, magnesium and aluminium. They are bound together by metallic bond. Metallic bond is the electrostatic attraction between the reactive of positive ion and the source of sea of electrons. Molecule covalent crystal. The particle consists of a simple molecule which are held together by weak van der Waals forces. Generally, this type of solid has very low boiling and melting point. Example, iodine, phosphorus and sulfur. Giant covalent crystal. Very large molecule consists of strong covalent bond binding its particle. The covalent bond gives gigantic structure. The particles are non-metal. Example, diamond, graphite and fullerenes. Generally, the giant crystal structure are hard and have high melting and boiling point. This is example for diamond. Example for graphite. Example fullerenes. Phase, triple point and critical point. Phase. The phase of a system are part of it which are separated by a distinct boundary such as solid, liquid and gas. Triple point. The point at which the three lines representing the solid, liquid, liquid vapor and solid vapor at equilibrium meet. Critical point. The point which is not possible to liquefy as gas, however great the pressure. Phase diagram. A phase diagram showing the relationship between the different phases of a given substance under varying conditions of temperature and pressure. This diagram shows the phase diagram of water. Curve ATB for solid phase, curve BTC for liquid phase, and curve ATC for vapor phase. For phase diagram, we divide to solid, liquid, and vapor. T is triple point and C is critical point. The line TC should represent the variation of boiling temperature with pressure. The line TB should represent the variation of melting temperature with pressure, and the line TA should represent the variation of sublimation temperature with pressure. Just for your information, at temperature between 273.15 Kelvin and 373.15 Kelvin under atmospheric pressure, the stable phase is liquid water. T is a triple point. Triple point of water is 273.16 Kelvin and 6 exponent -3 atm. At critical point, above which is not possible to liquefy as gas, however great the pressure. Phase diagram for carbon dioxide. Curve ATB is solid phase, curve BTC is liquid phase, and curve ATC is vapor phase. B is triple point and C is critical point. Same with phase diagram for water. Carbon phase diagram for carbon dioxide also we divide by solid, liquid and vapor. Line TC represents the variation of boiling point temperature with pressure. Line TB represents the variation of melting temperature with pressure, and line TA represents the variation of sublimation temperature with pressure. The phase diagram for carbon dioxide is more typical, showing a rightward sloping melting temperature line. Solid carbon dioxide is denser than liquid carbon dioxide. Triple point for carbon dioxide is 216.4 Kelvin and 5.2 atm. The triple point is above atmospheric pressure, so that at atmospheric pressure carbon dioxide sublime. So, dry ice, which is solid carbon dioxide, change directly from solid to gas. Okay, that's all.